Hi everyone, this is Fahad Mirza and I welcome you to the channel. Apple's M3 Ultra chip has started arriving and few people have already tested it, and thanks to them I have now some of the initial numbers and thoughts which I am going to share with you in this video. These numbers and thoughts are coming from the real world experience after testing this M3 Ultra. If you don't know what exactly I am talking about, I have been covering this latest Apple's powerhouse for quite some time on the channel since they announced its arrival. The M3 Ultra chip is Apple's latest powerhouse embedded in the new Mac Studio, designed to deliver unprecedented performance for AI workloads and other demanding tasks. Now, for us, the major attraction is that it might challenge the monopoly of Nvidia, which is better for everyone. So, in this video, I'm going to give you the exact numbers, and then also I'm not just going to praise this, I'm also going to give you an overview as why exactly it is slightly disappointing in few of the areas. With up to a 32 core CPU and 80 core GPU, the M3 Ultra significantly upgrades computational and graphical capabilities compared to its predecessors, the M2 Ultra chip. Also, for us, it stands out from the numbers in handling large scale AI models due to its sophisticated unified memory architecture, which allows high bandwidth memory usage, which is typically reserved for powerful GPU VRAM configurations, especially from NVIDIA. This architecture enables the M3 Ultra to tackle complicated tasks efficiently without the need for multiple GPUs, making it a game changer if it works as they are saying. Now, this is a comparison and number which I wanted to show you. The M3 Ultra has demonstrated outstanding performance in running the DeepSeek R1 model, which is sort of has become a de facto standard over the last few months, I would say. Now, DeepSeek R1, the full model comes with 671 billion parameters, and that is what has been run. And then these numbers have been shared with me, and this is what I'm going to describe to you as what exactly is happening here. Now, in summary, this model comprise this model the DeepSeek R1 got an impressive 671 billion parameter, and it is one of the best performing reasoning model out there. But it demands high bandwidth memory, of course, that would necessitate a complex multi GPU arrangement. If you have been following my channel for installation of this DeepSeek R1, you know what I mean. So what exactly these numbers are saying? So from these numbers we can observe that the performance detail of DeepSeek R1 running on different Apple Silicon variants. So let me first explain. If you look at the top image where we have run the larger parameter model, which is a DeepSeek R1 70 billion one, you can see that M3 Ultra, the 512 GB one, has run it by 13.68 token per second, and so on and so forth. Now, this is where Apple Silicon's M3 Ultra has demonstrated a remarkable leap in AI workload, that it is running it on single GPU. So which is quite impressive, I would say. Now, this is all well and good. It is even better when it comes to the smaller model, as you can see here on the token per second, which has improved a lot. And then the M3 has obviously ranked higher and ahead of other variants such as M2 Ultra, M4 Max, and notably M3 Air, which makes sense. So this looks good, but there is one big problem in my opinion. This actually reflects an important aspect of benchmarking too that is often overlooked, which is the relationship between prompt processing speed, or which is also called as PP, or initial processing of prompt, and context length. So let's first try to understand what is token per second. Token per second, or token generation speed, refers to the speed at which the hardware generates new tokens when it's already processed or loaded the initial prompt. And then we have PP, or prompt processing. This means the initial performance required to load and process the prompt context, which is the memory and computation needed before token generation can even start. This directly affected by the context length, which is the size of initial prompt text. Larger context length requires significantly more memory and computation time that potentially slows the generation process considerably. Now, uh, this data show the impressive generation rate, which is token per second, for new tokens once the prompt has already been processed. But these numbers do not clarify that how quickly this new chip can process large context, which means the prompt that could be thousands of token longs. Whether the performance advantage seen in output, which is token per second, extends to the initial prompt processing, especially at longer context, which could be 16,000 or something like that. This is a big question, which I still am looking the answer for. Now, this is really essential for the users who work with LLMs, as the initial prompt processing speed and supported context length are crucial. For example, running models that handle thousands of tokens for context can dramatically reduce performance on some hardware compared with their advertised token generation speed, as hardware can really struggle with larger context window due to memory bandwidth and GPU CPU. So just imagine you have just spent 10,000 US dollars on this chip, for instance, and then you are just running it dead slow, like a few hundred tokens per second, or just few tokens per second. That is not really cool, right? So 13 token per second, like if you think about it, it's very slow. The smaller models are a bit better. I mean, I would still like it more, but they are not that bad. So, but for bigger models, I don't think so that is making sense at the moment, in my opinion. If you just want to run it successfully on your M3 Ultra chip, yes, that can be done, as these numbers are telling us from the real people. Another good thing is that there is a superior energy efficiency. So it is consuming less than 200 watt compared to the traditional multi GPU setup, which is really higher power and substantial higher power for comparable performance. And of course, it eliminates the typical complexity of multi GPU setup and makes single system high performance AI workload feasible. But in my opinion, still the jury is out. Without clear metrics specifically about prompt processing times and practical context length efficiencies, I am not certain about how the M3 Ultra handles real world use cases in day to day workloads. So, if we just wanted to show you that it works, it runs, then I think 10,000 US dollars is pretty steep price for that. Anyway, let me know what do you think about these findings. Before I let you go, I also want you to look at our sponsors who are Camel AI. Camel is an open source community focused on building multi-agent infrastructures for finding the scaling laws of agents with applications in data generation, task automation, and world simulation. If you like the content, please consider subscribing to the channel. If you are already subscribed, please share it among your network, as it helps a lot. Thank you for watching.